we'd like to do is a lab on wavelength. Now, before you start your lab, you may want to print out this lab sheet. If not, you can just recreate this lab sheet on a piece of loose leaf paper. This lab should be relatively easy if you understand how to measure frequency, speed, and wavelength. So I want to make sure in this lab notes section you do a good job explaining to yourself how to get these three different terms. Okay, so the purpose of the lab is to look at the factors that affect the wavelength of a wave. This will be a very important equation that we're going to use for both sound waves and light waves. It also applies to all other waves, but sound and light are the biggies. You can open up the program whenever you're ready. There should be a link to it on your Google Classroom for today. And let's define our three terms and show you how you're going to measure them. Please make sure you understand how these work. You cannot get good data if you do not know how to work through this. Okay, so the first term is wavelength. And for wavelength, it's just the distance between two adjacent waves. It doesn't matter which set of waves you use, just make sure they are adjacent to each other, two successive waves. The first wave that comes out will happen at time 0, and you could label that as wave 0. Then the first real wave ends at wave 1, and then wave 2, and then wave 3. To measure wavelength, pick two that are easy to read. I'm going to go from 0 to 1, and I just measure the distance. Notice the scale, 100 meters. So each block is 10, and there's 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So this wavelength would be 120 meters. All right, you could have measured between 1 and 2 or 2 and 3. They all should give you 120. The second term is speed. With speed, it's very important that you focus on the wave 0, the wave that was produced at time equaled 0. You look at how far it traveled from the origin. So we start here, and it went 100, 200, 300, not quite 400, about 370 meters in a time of 7.245 seconds. Make sure you turn it from milliseconds to regular seconds. So it's distance divided by time equals speed. The final one is the trickiest one, and that's frequency. Remember, it's cycles divided by time. When you're counting off your cycles, the first is 0. So this is 1 full cycle, 2 full cycles, 3 full cycles, and a little bit. Try to have that little bit be as close to nothing as possible. So this wave that is just in the process of being created, get that as close to the origin as you possibly can. Okay, so in this case we have 1, 2, 3 waves in a time of 7.245 seconds. So it's 3 divided by 7.245, and that will get you your frequency, and that will be in hertz. Okay, so hopefully you understood how to get all three of the variables. For part 1, you're going to leave the frequency constant, and you're going to change the speed of the wave. For part 2, you're going to leave the speed constant, and you're going to change frequency. So let me walk you through part 1. Part 1, it's important that you only measure your frequency once and then don't change it. You will all get different frequencies which will be randomly generated. You will be able to get extra credit on this lab, so please try to measure these things carefully. All right, so let's show this. So here is the program. You're going to hit begin. You're going to start with no change in conditions, so you'll all get randomly generated numbers. Your waves will be produced. You can let as many go as you'd like. and some point before it goes off the screen, pause it. Okay? So in this case, the frequency is going to be pretty high. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 waves. Again, I got a wave right in the center, which is what I want. 25 waves divided by 13.0261 seconds. That is going to be my frequency, and I put that in up top here. Okay? To get my speed, I can use this for my first trial for speed. 100, 200, 300, 400, about 405 meters in 13 seconds. I divide and put my speed in here. For my distance between the waves, my wavelengths, I may want to zoom in a little bit. I may want to find one that's easy to read, so maybe I'm going to go with this guy here because he's right on a line, so that's 10, not yet 20. I'd go about 18 meters. Okay? And I'd put that in for my distance between the waves. I then come back here and watch. To get a new speed, you hit end, you go change speed, you pick a speed. Try to have all your speeds in different ranges, so I'm going to go with a really fast wave this time. I hit start, and before that first wave disappears, I pause it. Let it go as far out as you can, you'll get better results, but don't let it leave your viewport. Okay, I have 100, 200, 300, about 392 meters. I divide by the time, and that is my speed. For my wavelength, again, I find one that's easy to read. Here's one that's right on a line. 10, 20, 30, 40, 50. It's about 50 meters. All right? And then I would end it. I'd go in, I'd pick a different speed. I already did one that was really fast, so maybe I want to get one that's really slow. Okay, I let it go out. Maybe I want one that's in the lower range but not real slow. I let it go out. I get one toward the middle. I let it go out. And I do the same measurements every single time. So you're going to do a total of 5 different speeds, get a nice range. You can use the default speed for your first one. Again, you'll all get different values, so don't try and compare yours with anybody else. Yours will be unique. Get yours as accurate as you can because there will be chances for extra credit. Then for part 2, this is where things get a little tricky. This time you're going to pick a speed. I would suggest not having a speed that's very fast. I would go more toward the lower end. You don't have to go super slow, but somewhere in the lower quarter would probably be a good speed to use. And then you're going to do 5 different frequencies. So let me check to make sure my speed's in the lower part. This looks great. Again, I don't want it too slow, but I definitely don't want it too fast. Okay, I then end it, and to change my frequency, I come here. It says click on the button in the center of the screen 3 times. This will establish your frequency. So if you want your frequency to happen quick, click quick. 1, 2, 3. If you want your frequency to be gradual, put a long spacing between your clicks. So click, click, click. Your waves will be created at the same frequency that you clicked. Make sure you don't do a quick click and then wait, because those clicks were not consistent. You have to click with a constant frequency for it to establish properly. All right, and then it should be off to the races. I know this lab is pretty difficult, So I'm giving you 2 days to do this. You'll have Thursday, you'll have Friday, and because of AP test, it's not actually going to be due to be turned in until Sunday at midnight. Don't wait too long, and try to make sure you have your data done to the best of your ability to get your extra credit. When you're all said and done, write up your conclusion. Keep it simple, but make sure it's complete. How does speed affect wavelength? How does frequency affect wavelength? And again, talk about things like what happens when you double the speed, what happens when you double the frequency.